Let's learn physics. So Zul, well, you might question, what is it that we are going to learn in today's class? Now, in today's topic, we are going to learn about wave. Well, wave, isn't there like a lot of phenomena when it comes to wave? Now, you are exactly right. Wave has a bunch of phenomena. Some of them are like diffraction, what else? Reflection, refraction, and last but not least, interference. Now, in today's topic, we are going to learn specifically regarding interference of wave. Now, here's the deal. To some of you, you might question, now Zul, what is interference? Or even, what is wave? Now, let's not be biased. I understand my audience. Some of you may be an actual physics learner, and some of you are not. Some of you may be just interested to learn what physics is. So, when it comes to wave, we have to question ourselves first. What are they? When it comes to wave, what do we know? All we know is that wave is all this jiggly stuff, right? The one with sine graph, or the one with cosine graph, right? My bad, cosine graph, there you go. So, before that, let us first question ourselves. Is there wave around us? Would you consider light as a wave? Or water as a wave? So, what if I tell you that wave is all around us? Now, the question was whether is light a wave, or how about water? Are they wave? Now, be it light, water, or even sound, they are all wave. But how? Well, we'll find it out together. Welcome back. So here is where we will figure out on the stuff mentioned before, whether light, sound, or even water can be a wave. Now, here's the deal. As you can see, this is a diagram that has been drawn. Now, before we further survey on whether water, sound, or light are wave, let us learn first on what wave is in the first place. Now, as you can see from the diagram of a wave, you can see all these black dots. What are they? They are called particles, and these particles are the one that creates wave. How do they do so? It's basically when these particles oscillate, right? There's a rhythm to it. When they oscillate in phase, these will then create wave. So, as long as you have these particles and a transfer of energy, you will have wave. And because of that, I conclude that water, sound, and light are wave. In details, as you can see from the ripples of water and from the wave that is created by sound, and last but not least, from a bulb that creates a light wave. So, now that we have covered the whole, or basically the general idea or concept regarding what wave is, now let us go further into the main topic of the day. Now remember how I've mentioned there's a lot of phenomena in wave. But specifically speaking, today we will be learning interference of wave. So, before I even draw what interference of wave is, try to visualize or imagine what interfere really means in the first place. Okay, so let me just first start with my first drawing. Here I have a wave with amplitude A. Then I draw another wave from another source with the same amplitude A. So here we call them as crests. Alright? Now, two crests with amplitude A collide with each other, or in other words, interfere. What will happen? Try to imagine. Well, if you imagine correctly, you guessed it right. When they interfere with each other, the amplitude will add up. Or in other words, two waves with each amplitude A will produce wave with 2A amplitude. Now, what else that interference of waves offer is when, let's say I have a wave with amplitude A. Here is again crest. This is crest, this is crest. But in this case, I will introduce a new character. A new character called throw. Well, throw, even with amplitude A, the only difference is that A here is negative. So what will happen? Well, I guess you can imagine. What will happen when you meet crest and throw is that you will get 0 amplitude. And honestly, that is the magic of interference of wave. How can you have these two colliding waves creating nothingness? Now, we'll come back with the application of interference of wave in daily life. Now, remember how I've mentioned that we are going to talk about the application of interference of wave. But here's the thing, what does all these plays have to do with the application? Well, here's the thing. Let me show you the magic of interference of wave, especially in this scenario. Follow me. Now we're currently at a bus stop, and also we have a motorcycle passing through and a few cars. Well, as you can see, the situation is very loud. Well, there's another car and some bunch of motorcycles. Very stressful, right? But don't worry. With the magic of interference of wave, let me introduce you to something called noise cancellation. And with just a little bit of magic, all I have to say is, hey Siri, turn on and it will turn this situation into this. Okay, now you might wonder, how is it possible for us to change those very loud noises into something as if we're alone in a room? Well, as I've said, introducing noise cancellation, these earbuds with the ability of cancelling noise, how does it do so? Well, as I mentioned just now, through the power of interference of wave, how it cancels sound, how it cancels wave. By introducing a wave that is out of phase into another wave, thus we're able to stay peaceful wherever we are. And that is the magic of interference of wave. See you guys later, and thank you for watching.